exciting Friday evening plans to be here with me tonight. Now, we will be discussing my journey to astronomy, and then we'll discuss the research that I did in my internship and everything that followed after. And it's, like Jessica said, it's highly unusual for an undergraduate student such as myself to be up here speaking with you all today. Usually we have professionals in the industry, like astronauts or graduate students or full-time researchers making groundbreaking discoveries. So I hope that you guys can still learn a little bit of something, even though I'm still learning myself. So without further ado, I'm going to need us to take a journey back in time, specifically to my childhood. So this is a photo of my sister and I at the California Science Center, and behind us is the Endeavour space shuttle. Now, I pretty much came out of the womb interested in astronomy. The first thing I ever wanted to be was an astronomer. And me and my brother would lay out blankets outside in the middle of the night to watch meteor showers, and we would have to beg our parents to let me stay up past my bedtime. And we would also go up to the mountains to watch lunar eclipses and other meteor showers and solar eclipses. But unfortunately, you're never too young to get your dreams crushed, because a family member told me at about the age of 8 that astronomy wouldn't lead me anywhere in life, and that it wouldn't make me any money. So what did I do? I decided to pivot to a different career path that would make me even less money, and that was journalism. So there was a whole host of things that I wanted to pursue in life. For a while after the astronomy dream died, I wanted to be a doctor, and then I wanted to be a lawyer. And then I found a passion for writing in high school. Writing was very much my escape from a lot of things happening, and I loved it so much that I decided that I wanted to do it for the rest of my life. And I was pretty good at it, I'd say. I went from being a student writer to one of our editors in class, and I even won Huntington Beach High School's first National Journalism Award, the Best Snow Award. Thank you, okay. I was not expecting an applause, but all right, yeah, so I decided this is what I wanted to do. I wanted to go to college to study this. When I graduated high school, this is me when I was a lot cooler and I had a septum piercing and red hair, but when I graduated high school, I had absolutely no direction in life. I was failing several of my classes. I was worried that I wouldn't even graduate because I barely passed some of my English classes that were requirements to graduate, and I didn't really know what I wanted to do. I knew I liked writing, but I didn't really know how to get there or how to go anywhere in life. So while all my friends were going to cool four-year universities everywhere from UCI, and one of my friends is in the Army now, I came here to OCC. And the very first impression that I had of this, I knew in my heart that community college was the right choice for me, but I had to deal with the stigma. Of course, there's a lot of people out there that think community college is something to be looked down upon, and a lot of people in my family felt this way as well. So when I first came here, I didn't really know if I found myself. I didn't really know if I wanted to be here. I kind of only went to college because I wanted to get a degree in journalism. But in hindsight, coming here was single-handedly one of the best decisions I could have ever made for myself. So during my first semester here at OCC, as still a journalism major, I took Astronomy 100 to fulfill my general education requirement for physical science. And this decision single-handedly changed the rest of my career here. So I learned about really cool things like stellar evolution, and learned that my favorite particle is a neutrino. And I got to look at the moon through nighttime telescopes, which I believe are outside tonight after this presentation, so you can do this just like I did. And it wasn't just the class that was interesting to me. This class refueled that childhood passion of mine, but I would not be here today if it wasn't for the professor that taught that class, because she fueled that curiosity as well. So thank you, Jessica, for changing my entire life. So now I found myself at a crossroads, right? I found myself at the intersection of science and art, and these two felt like polar opposites to me. I love writing, but I also really love science. So I figured the best course of action would be to combine them. I could do science journalism. So I started researching this career option, and I found a wonderful opportunity, a wonderful master's program in science communication at UC Santa Cruz. I had visited UC Santa Cruz before, and I fell in love with the campus. I thought it was the best of both worlds. It was close to the ocean, which I can't seem to live without, and in the redwood forest. So I figured that this was the dream, to write about science in a place that I found really cool. But upon further research, I found that they don't really need a degree in journalism. The students that they're looking for have science backgrounds. Of course, you need to understand the science that you're writing about. And, you know, I didn't know what science I would get a degree in. I didn't really like biology enough to go through the effort of getting a degree. I took AP Chem in high school and kind of didn't really like it. So the only science that I could see myself studying was astronomy. And in order to understand astronomy, you absolutely need to understand the underlying physics. I'm going to leave this up here for a second and let you chew on it. Whoa. So I changed my major to physics before ever taking a physics class in my entire life. So math is not the subject that inherently comes to me. I'd like to think it's like English and reading. These subjects are more comfortable for me. Math is something, it doesn't entirely click in my head like it might for other students. I actually practice it and do a bunch of problems over and over and over again to finally get it. I did fail Calc 1 twice, so I eventually got on the third time though. And physics is a subject I actively avoided in high school. My first experience with physics was around the age of 10. I went to a science museum, and when I got to the physics exhibit, I got a massive headache. So since then, I associated physics with headaches and pain, and to a certain degree, it still is, but I at least enjoy that process now. So making this jump, when I tell people that I made this jump from journalism to physics, two polar opposite subjects, they often look at me like I'm crazy or like I'm dumb, and sometimes like I'm both. And I honestly don't blame them, but I knew in my heart that this was the decision I needed to make in order to get where I wanted to be in life. And again, the dream at this point was still science communication. And about a month or two after I officially changed my major, I got a job here working at the planetarium as a speaker, as a presenter. And the reason why I got this job is also because of that Astronomy 100 professor, Jessica. So not only did she change my whole career, she also got me a job. So thank you for giving me money, Jessica. Now this job was unlike any other job I had worked in the past. I got to do really cool things like helping kids launch rockets and hanging out with some of the biggest nerds I've ever met, messing around in the gift shop, running public shows for audiences such as yourself, putting solar telescopes outside every Saturday and getting to look at cool things like sunspots and solar prominences. And we always have to remind people that the solar telescope is in fact safe for your eyes and that we're not getting all these lawsuits because we're blinding people. And we also hold events such as our solar eclipse event for over 2,000 people. So what we do here is it's all about science outreach. But probably the pinnacle of my job here is teaching K through 12 students. So multiple times a week, I come into the planetarium very early in the morning, earlier than I'd like to. I'm not a morning person, and I have to teach K through 12 students. Now here at this job is where I truly learned what I wanted to do with my life. I learned that I wanted to teach. But I have taught probably about 7,000 to 8,000 K through 12 students by this point, and that's enough to tell me that I don't want to teach K through 12. So I want to teach college students. And so the science journalism dream took a little bit of a backseat, and now at the forefront was teaching college. I wanted to become a professor. About a year after I started working at the planetarium, last, let's say like January or February, or this January, February, I got forwarded an email about this research internship, the Advancing Space Sciences Through Undergraduate Research Experience at UC Berkeley's Space Sciences Lab. Now, when I got forwarded this email, I thought it was a scam because I had never heard of this thing before, and I didn't even know Berkeley had a whole lab for space science. And after further investigation, I learned, okay, this opportunity is legit, and then I forgot about it. And it wasn't until about 5 days before the deadline that one of my friends came up to me and said, hey, are you applying to that internship? And I said, what internship? And so I opened the application, I got very overwhelmed by the questions, it was fairly long, and I closed my laptop. And then I ended up finally doing the application the day of, and I submitted it 30 minutes before the deadline. Now, procrastination is something, it's probably my biggest weakness, and it hasn't gone away, as you'll see later in the presentation. But I thought submitting this application was a complete shot in the dark. At this point in time, I had only taken 2 physics classes, but neither of these physics classes were calculus-based, and for those that are STEM majors, you'll understand that we have to take calculus-based physics. And I had no research experience, and I was on my 3rd time of taking Calc 1. So I thought I was grossly underqualified for this opportunity. About a month or two after I submitted that application, I got an email that they had selected me. I was one of 300 applicants and 10 students total to get selected for this research opportunity. And that's a 3% acceptance rate, which is less than Harvard. I will always tell people that. Yeah, and when I got this email, I was very excited, but I also could feel the imposter syndrome setting. I thought they had sent the wrong person this email. I thought that maybe there was somebody else named AJ that had applied and that they got the wrong person. I didn't think that I deserved this, but regardless, I put that feeling aside and I accepted this opportunity wholeheartedly. So a few months later, after the semester had ended, I packed my bags and I was off to Berkeley. And this was the start of a very tumultuous journey. This isn't even my suitcase. This is my girlfriend's mom's suitcase, and I still have to return it to her. And I also showed up to the dorm 2 hours before I was allowed access into my room. So this is us sitting outside, waiting for 2 hours before I could actually enter my room. And I also had only ever been on a plane about maybe 3 or 4 times prior to this experience, all of which were when I was a child. So my girlfriend also had to help me learn how to navigate an airport. And after doing that, and finally getting settled, I realized I didn't bring anything with me. I brought my laptop and about half of my closet in those suitcases. I didn't bring shampoo, I didn't even bring toothpaste, I didn't realize that I was actually moving somewhere and not just going on vacation. So the first thing I did was I put my bags away and we went to Target to go buy everything from bed sheets to soap. And within the next week, my first week of being there, it was an absolute dream. This is the view from the top of the lab. It's on top of a hill, and you can see everything. You can see most of the bay. You can even see the Golden Gate Bridge on clear days. And this is the iconic Sather Tower, which I very much enjoyed looking at all the time. And this is their mission control room that they have in their lab, and we got to watch in real time scientists and engineers controlling NASA satellites, this solidified just how cool and real this lab was. But after the first week, that feeling of euphoria faded, and I got extremely homesick. So week 2 is when I started to contemplate whether or not I even wanted to be there. I felt bad that I was getting homesick when I was still within the same state, and then I realized just how big California is. I was 6 hours away from home. This was the longest time I've ever spent away from home, completely on my own, in a city that I had visited once before, with friends, well, they weren't friends at the time, but other interns that I didn't know, without my car. So it was extremely difficult to navigate. And this is when the imposter syndrome truly started getting worse. I started to question whether or not I should even stay and continue for the rest of the summer. And this is on week 2 of 10. But then I remembered some words that my mom had told me. Now, unfortunately, my mom passed away earlier this year. And about 3 months before she did, maybe 5 months before she did, we went out to lunch together. And at this lunch is when I told her what I finally wanted to do with my life. I want to teach astronomy and physics. And my mom was someone, she always took what I said with a grain of salt, because she saw me literally jump around from everything. She saw me, one day I wanted to be a doctor, one day I wanted to be a lawyer, the next I wanted to be an astronaut, and then the next day I wanted to do something completely different. So when I told her this, she had no idea what this astrophysics thing was. My mom immigrated here at age 14 and had to leave her education behind. And the only thing she ever asked in return of me and my siblings was to go to school. So that's exactly what I did. And when I told her what I wanted to do with my life, how I wanted to teach and be a professor, she couldn't even begin to comprehend what it was that I wanted to do, but she told me that no matter what it is that I wanted to do with my life, that I could get there with some hard work and perseverance. So with her words in mind, I dedicated myself fully to the next 8 weeks of my program there. And I enjoyed the process along the way, even amidst all the frustration. So with that, here is what I actually did. So I researched a topic, a phenomenon called Enhanced Aurora. And for those that are familiar with the aurora borealis, it's similar but also not similar. And we'll get into that in just a second. But first, before anything, we need to understand how regular, quote-unquote, aurora is formed. So here's a very low-quality video from NASA of the process that happens. So you have these particles coming from the sun. They travel all the way to planet Earth, hitting our magnetic field, giving those particles so much energy, and then this snapping thing happens. That was somebody else's project, not mine. It gives them so much energy that they come streaming down the magnetic field lines. They interact with Earth's atmosphere and cause it to glow. And the color that the aurora glows is as a result of the chemistry, the atmospheric chemistry of the molecules that they hit. So that iconic green color of the aurora that we see comes from oxygen, and the bluish color comes from nitrogen. But you don't really need to know that. Okay, and this is a video also from NASA of a view of aurora at low Earth orbit. I would like to see this phenomenon. I've never seen the Northern Lights. So I think after researching it for 10 weeks, it's going to make it a lot more special when I eventually do. Okay, so now that we've covered how regular auroras form, that process is called particle precipitation. I want you to hold on to that for a second. There's other things. We call them ALFs, or aurora-like forms. They look like aurora, but they don't exactly behave like it, and they don't have the same background. So we have this weird thing, this mauve color arc called strong thermal emission velocity enhancement. And then we have this thing that is less convoluted to say, the picket fence, because it looks exactly like a picket fence. Now, I don't want to say strong thermal emission velocity enhancement for my entire presentation, so we're going to shorten that to Steve. And that is the real name that scientists gave. It comes from the movie Over the Hedge. It's this whole story, but it's Steve now, officially, in scientific papers. So this is the spectrum of a normal aurora. Now, if this is overwhelming to you, don't be overwhelmed. I'm only going to point out a few things to you. All you need to know is that regular aurora has a little bit of blue, a lot of bit of green, and we don't really care about the red for this presentation. This is the spectrum of Steve. It looks totally different. It displays this continuous spectrum. It still has that green and quite a bit of red, but we don't really know why this is happening. We have theories, but we need to prove them. This is the spectrum of the picket fence. So it still has all this green, but there seems to be a lack of blue, and that's a problem. So we've learned that particle precipitation ionizes nitrogen and leads to the blue color. If there's no blue, then it's not particle precipitation, meaning that the aurora that we're looking at, quote unquote, is imposter aurora. It is not normal aurora, like we would call it. So we need to understand why this is happening. Now, there's a theory at work. The theory is that there's an electric field parallel to Earth's magnetic field. If you have any questions about that, I cannot answer that. That is beyond my education. If you have any questions, I can probably forward you the email of my mentors. But another aurora-like form is this weird thing called enhanced aurora. It's similar to that picket fence thing we looked at earlier in that it's too green. There's way more green light than there is blue light, and that's weird because that signals to us that it's not caused by particle precipitation. Okay, and this is a photo. You can see regular aurora and then the enhanced aurora. So we're going to look at next steps. So in order to understand the enhanced aurora, we want to shoot two rockets, one through the actual enhanced layer, which is the very, very, very bright and very, very, very green layer, and then another rocket through this more normal layer on top. And if we can do that, then the next step would be to send rockets through Steve and the picket fence and learn more about those. Those are the really weird ones that we want to understand. But first we need to understand this one that's a little less weird. And then that's where I come in. So in order to convince NASA to fund the grant for our rocket, we need to give them some details. Specifically, we need to tell them how frequent and stable they are. Is it even possible, is it even feasible to shoot a rocket at one of these things successfully within a 2-week launch window? And currently, before I came in, there wasn't a concrete way to detect enhanced aurora in spectral data. So I created that algorithm. I built the method to find this weird enhanced aurora thing in data. And that was certainly a process in and of itself. My mentors wanted me to have this algorithm done by week 3. I spent the entire summer doing it. Okay, so this is a video of Enhanced Aurora, just so you can visualize it a little bit easier. So it's characterized by this thin, luminous, and green layer underneath regular aurora. So that is the thing that we're looking for in data. Okay, so my data came from an instrument called the T-Rex spectrograph. It's not that kind of T-Rex. It's a little bit less interesting than that, and a lot of bit more complicated. This is the T-Rex I'm talking about. It stands for Transition Region Explorer Spectrograph. It's an instrument in Rabbit Lake, Canada, and it captures emissions everywhere from that blue spectrum, around 400 nanometers, to 800 nanometers, closer to the blue. You don't need to know those numbers. Okay, so this is the first graph that I made, and I made this using code that my mentors provided to me. They were very, very generous. They gave me a lot of code to start with and a lot of good data to start with. They essentially just wanted to make sure I found my footing and I knew what to do. So this is a spectrum of Enhanced Aurora, and we already know that this guy we're looking at is Enhanced Aurora because my mentors did the hard work for me. Again, this is just to make sure that everything was moving smoothly. So we can see that there's a whole lot of green and not that much blue. And this is the same graph, but in a different way. So this one that we just looked at is how bright it is, and this is also how bright it is. You can see it visually though, but you can also see at what elevation angle it's the brightest. Okay, so those graphs were 2-dimensional. Now we need to make a 3-dimensional array, a data cube, in order to learn more about this thing. So we are working with 3 main parameters here. Wavelength, which will tell us how much green and how much blue is there. Times, we can find out the times in which these enhanced aurora things are happening. And elevation angle, which tells us where these enhanced auroras are. And for the next bit of this presentation, I'm going to be using this word keogram. A keogram is a graph that displays auroral intensity, or how bright and what color an aurora is over time. Okay, so also, I'm going to try to make this research as simple as possible because I myself barely understand what I did. I only just started actually truly understanding the science behind it at week 10, which is the last week. So all you need to know is that the units I'm using in the following figures are completely arbitrary. All we're looking at is ratios. So if you think about it like you're cooking, it's a 2-to-1 ratio or a 4-to-3 ratio. There's no units attached to it, it's just a number. Second thing you need to know is that the theoretical green to blue ratio of Enhanced Aurora is above 26. 26 is the only number that you need to keep in mind for the rest of this presentation. If it's above 26, that green to blue ratio, it's what we're looking for. If it's below 26, we don't really care about it. But we expect this ratio to be a lot higher, between 30 and 60. So these are some of the initial graphs that I made. This is all wavelengths, so all colors. And we can see it's extremely bright. We can see in this one, which is just looking at the green light, that it's extremely green. But then we ran into a problem. When we look at the blue wavelengths, it's way more blue than we're expecting it to be. And so when we make the ratio plot, looking at the green to blue ratio, our ratios are completely thrown off. Now again, this is a sample of what we already know to be Enhanced Aurora. I'm just testing things at this point. And they're way lower than we expect them to be. So what's the problem? The data itself was contaminated, which happened a lot later on. So we can see that this line down here is not starting at 0. It's starting closer to maybe 100 or 200. And that's not helping us. We're dealing with very small nanometers, so every number counts. But we can bring that line back down to 0 and get much better results. So now everything is working accordingly. We can see that our blue light has decreased closer down to the level that we're expecting. And here is our very first sample of Enhanced Aurora. So thank you all very much for coming. Okay, no, we're not done. We have so much more to do. This was only done about like week 3, and things got more complicated for me. So essentially now, my job was to do it all over again, but make it even better. So my mentor now was curious to know what the distribution of ratios looked like over the course of this day. And this day, February 21st, 2023, will forever be burned into my brain because this is the day I was working with a lot. So as we can see, there's a lot of blue points, an abnormal amount of blue. And I asked my mentor, why is it weird? And she told me, quote, I don't know why it's weird. So my task was to figure out why. And we found that there was a problem. The expected green to blue ratio, like we covered, of regular aurora is 26. Expected green to blue ratio for enhanced aurora is above 26. The mean ratio in this scatter plot was 9.28, so totally off. And we found out that the data was also contaminated. We didn't completely get rid of that contamination. So these red points are areas that are essentially too blue. And we figured that that was happening because of sunrise and sunset causing things in the atmosphere to appear more blue. So all we had to do was filter that out, filter out the sunrise and sunset time. And now we're getting a plot that looks a lot more like what we're looking for. So this line is at the theoretical ratio of 26. So everything below that line are possible enhanced aurora candidates. Everything below this black line is more what we're interested in because these ones have the highest ratios, which is exactly what we're looking for. Okay, so what have I done so far? I just spewed a whole bunch of graphs at you, and I want us to get us up to speed. So first, I corrected those spectral baselines to make sure that the ratios are not artificially deflated. Like we looked at earlier, how our ratio plot was showing a ratio maybe less than 20, and we were looking for something that was way above that. Then I filtered out the sunrise and sunset times to make sure that we're not taking these points that are too blue into consideration. So is the algorithm ready to use now? No, there is still so much that has to be done. So essentially now is my make it better arc. So I had to do this whole spectrum thing all over again, but do it in a much better way. So we found out that the corrections that I was making earlier weren't entirely sufficient. There were days that I would run this program on and it would just be completely wrong. So we did something called a rolling average. Essentially, I used 30-minute windows over the course of this day. I found the average of those 30-minute windows, the average wavelength, and I brought it down, the average luminosity, sorry, and I brought it down by that amount. And that makes things much more accurate. Okay, so I'm going to bring this graph back from the very beginning. And if you notice, you might have to look really carefully. I know the dome is kind of distorting things a little bit. That this line is ever so slightly curved. And that is a very big problem. You can extract that data, specifically the green data, and look. And the line looks fairly straight, and you wouldn't think that this would cause such a big problem. But when you zoom in, it becomes really bad. So this is the specific type of green we're looking for. It's 557.7 nanometers. Again, you really don't need to know that number. All you need to know is that this is where we want the points to sit. And they're going pretty much everywhere but that, which is a very big problem. And it was also happening to the blue. And interestingly enough, the blue distortion had this triangle shape, and we're still trying to understand fully why. But this one's even worse. It's going everywhere but this 470.9 line. And the people running the instrument, the T-Rex, are from the University of Calgary up in Canada. Now, some folks from the University of Calgary reached out to my mentors and said, hey, we actually think this distortion thing is getting worse with time. So they wanted me to confirm that. So I ran data all the way from 2019 to 2024, which almost broke my laptop. And we confirmed, yes, this distortion is getting worse over time. And we can see it's also happening with the blue. Interestingly enough, we can see that sort of triangulation happening here. Now, we think that this distortion is happening due to some instrumentation error with the actual spectrograph. Maybe it's decaying over time. And that's the engineer's job to fix it. My job as a scientist is to just correct for that. So we needed someone to fix that for sure. So I corrected for that. The next thing I had to do was to take moonlight into consideration. Now earlier we saw we filtered out sunrise and sunset, but we didn't even begin to consider the moon and how the moon also causes things to look more blue than usual. So this is a particular day where there happened to be a full moon. And we can see just how bright it is, and especially in the blue color, we can see that it's making things a lot more blue than they should be. So we added a part of the algorithm where it filtered out any points where the sun or the moon was above -15 degrees in elevation angle. And with that component, we were able to completely filter out those times. So this time slot is where the moon or the sun was too high and was making our data unusable. So now, the algorithm is finally ready to use. And after running my code for about 8 hours overnight, this is the result that I got. And thank you. So all of these red points are enhanced aurora that we've detected with all the corrections in place. The algorithm still isn't perfect, but it's way better than it was at the beginning of the summer. And you'll notice that we have this number here, this random number that I haven't mentioned. These red points are sitting at, they have 3 different parameters. 1, the enhanced aurora that they're detecting have to last at least 5 minutes. Because if they're not longer than that, then if we shoot a rocket through it and it disappears in 2 minutes, we're not going to hit it. Second, they're also enhanced aurora where the elevation angle isn't varying too much. Because if it's moving around in the sky, if it's in one place, you shoot the rocket and then it moves, that's also a big problem, and NASA's going to be very mad. And these are also points that have the highest ratio. So we ran the entire month, which is February 2023, which is why it took 8 hours to run, and I need to get a laptop with more RAM, for sure. 8 gigabytes is not enough. These are also points where they are the 80th percentile of green to blue ratio, meaning they're the top 20% of ratios. So these, with all those considerations, are areas that we are the most interested in. These are the types of enhanced aurora samples that we're going to take and do further statistical analyses on to answer those questions that we had at the beginning. Now, what have we done? So we have concluded that enhanced aurora can accurately be identified in spectral data, which we wanted to do at the very beginning of the summer. Now again, we were supposed to be done with the algorithm by week 3, but it took us a long time. Lots of turns because there kept being more road bumps, more things that we didn't consider prior kept coming up. So what's next? Next, we need to fine-tune this algorithm because again, it wasn't perfect. This is my first time doing research, so don't want to trust an undergrad completely when there's a lot of money from NASA on the line. Then we need to use that fine-tuned algorithm to process further data and characterize enhanced aurora. Answer those questions. How stable is it? How frequent is it? When do they occur? Where do they occur? And then we need to answer that question if it is truly feasible to launch a rocket through one in a 2-week launch window. Okay, so outside of the research, I had the time of my life up in Berkeley. I got to spend my whole summer with 9 of the biggest nerds I've ever met, and most of which I'm in contact with to this day. I will be seeing them at a conference next week, actually. Then I got to live my cute little college life in a college town. Berkeley's very, very cool. It has a very unique charm to it, and it's very much a college environment. And I got to go to cool places like the Palace of Fine Arts in San Francisco with my girlfriend. I absolutely love San Francisco, so being across the bay for the whole summer was a dream. Only a 40-minute BART ride or so. And these are some other cool things that I did. So one of my friends, his project was to do research on the sun, and because they were launching a rocket to measure it. And this is the actual rocket that will be going into space soon, or at least low Earth orbit. And they needed to align some things. That's a bunch of engineering stuff that I don't understand, frankly, with lasers. So we went to the lab in the middle of the night and saw them doing it, which is really, really cool. And then me and my friends crashed Stanford wearing Berkeley merch, and we got a lot of dirty looks. We went there for another presentation, and it was very, very good, but it was fun going there as Berkeley students. And we were walking around Stanford talking about how clean, how cool it was, and how very prestigious it felt. And somebody that was walking by us in downtown said, are you guys from Cal? And we were like, yeah, is that obvious? This is me presenting my research poster at the end of the summer. I didn't even think that this would get done at the beginning of the summer. And I actually, the procrastination never went away. I submitted it 2 hours after it was due. And I'm surprised that it got printed. So sorry, Sam, for giving you a headache. And then this is me and all my other friends, all my other fellow interns on the last day of the internship presenting our final projects. We each got individual projects and got assigned 1 to 2 mentors to collaborate with. So everybody had projects ranging from atmospheric stripping on Mars to terrestrial gamma ray flashes on Earth. It was very cool. So now for those of you that are in the audience that are also undergraduate students, this is what you can take away from this. What can you learn? If you're interested in going to research, you need to understand it can be really, really fun. I had a lot of fun doing it, but it is frustrating at times. It can be a real headache, but you will definitely build a lot of skills that you wouldn't have been able to build before. It teaches you a lot about yourself and about things you can learn. And I encourage you all to apply to any opportunity that seems interesting to you. Like I told you all, this internship was something I thought was a complete shot in the dark. I didn't think I would even get it, but I applied because the worst that they can say is no. So put your name out there, submit that application, try to go for that job. You'll eventually land somewhere that you'll be surprised about. Now, here's my advice, whether or not you're going into research. You have to conquer imposter syndrome. Now, this is a piece of advice that I'm still learning myself. This is an ongoing issue. And you have to also remind yourself that everyone else around you, your friends, your fellow students, your peers, even some of your professors and mentors, they're very much still learning. Education is a never-ending journey. So even if they look like they know everything and they have it all together, they probably don't. Then you have to learn to be comfortable with change. As you can see, based on all the research I presented, things took a turn. They went in all different directions that I didn't expect them to go into. So you have to adapt to this ever-changing environment. Then you absolutely have to be patient. My patience was very much tested over the summer. And good results take time and effort. So it's okay to slow down. It's okay when you run into a wall and you have to backtrack. You just learn patience along the way. And it's okay if things don't go as planned. Then I encourage you all, no matter what field you're in, to talk and network with others. One of the biggest pieces of advice that I've ever been given is it's not about who you know, it's about who knows you. If some people in higher positions in that job that you want know your name, they are familiar with you, not just on a surface level, you have to build genuine connections. Then they can put your name out there, they can recommend you, and maybe you will get that job or internship that you're looking for. Then this is a very important one for me. Build a support system and practice self-care. There were many times throughout the summer that I was overworking myself. I was working about 40 hours a week, so I was going 8 to 5, so it's a bit more than 40 hours, I think. But there would be days that I would stay at the lab from 8 in the morning till like when it closed at 7:30, which is not good and definitely burnt out a little bit. So you have to build that support system, whether it's friends, family, pets. I wish I could bring my dog up there. And you have to take care of yourself as well. You can't do cool science, you can't do the cool thing if you're not eating, you're not sleeping, you're not taking care of yourself. Then my biggest piece of advice is you have to enjoy your work. And if you don't, please pivot to something else. Choose happiness every single time. So this is what I want to do with my future. When I leave OCC, I will have 3 associate's degrees, one in physics, one in math, and one in astronomy. And I want to transfer to a 4-year university to pursue a bachelor's of science in physics or astrophysics. I will be the first in my immediate family to graduate college, and one of few in my extended family to even attempt college. Then I want to go to grad school and get my PhD in astrophysics. I'm putting the statistic up here that 6.6% of astronomers and physicists only are Hispanic and Latino. Not to make myself seem special, but to put it out there that despite socioeconomic barriers, you can make it. You can do the thing you want to do, even if there's not many people like you in the field. Then I want to become a professor, hopefully with tenure, and it would be really, really cool if I could come back to OCC or another community college. I really enjoy the community college environment, and it would be really cool to teach students like me. And then, of course, we can't forget the original dream. I still want to pursue science journalism. Writing is something that has never stopped for me. It's something that I still incorporate in my life. I write still sometimes poetry. Sometimes I try to write articles to myself. I am journaling all the time. It's something that I very much lean on still to this day. And with that, here's a final video of Enhanced Aurora in case you forgot how cool it is. I'd like to thank you all very much for joining me here today. Once again, my name is AJ Juarez. Thank you. Thank you all. My understanding now is that we're opening the floor to a Q&A session. Jessica, is that still the plan? Okay. For those of you, if you don't have questions or if you're feeling restless and want to get outside, we do have our telescope set out, yeah? Is that? Yeah, okay. We have some nighttime telescopes set up outside, so we're not going to hold you hostage. If you're sick of me already, please be my guest and go check out those cool things outside. For those of you that do have questions, I will be in here to answer them. It can be anything. I'm opening the floor to questions about my research or questions about myself as a person, or if you want some advice, I can give that to you too. So I'll be here. Yeah?
So T-Rex that we used to remember thing, right? So is this technology still relatively new or more updated or?
Okay. Yeah, so she asked if the T-Rex spectrograph, the instrument that we're working with, is the technology in it fairly new. I actually don't know when the instrument was built, but I do know that it's been collecting data in Rabbit Lake, Canada, no earlier than 2019. So I would say, yeah, it's pretty new. I would bet. Yes.
You probably heard it a lot lately, but what season and where would be the best to see enhanced aurora?
What season and where would be the best to see the enhanced aurora? So enhanced aurora, we currently think that it occurs as often as 50% of the time that normal aurora occurs. So the answer to that is go anywhere where it is best to see the regular northern lights. Those places would be, first and foremost, during winter, where it's dark. You don't want to go during summer. And you want to go either up north or down south, but I would recommend going up north. I think the best country to see it is Norway, but obviously, Norway's a trip. So Canada would probably be my next recommendation. I haven't seen it myself, so I can't really give you advice for how to track it down. But yeah, we are in a period of time right now called solar maximum, which is when the sun is the most active. So that's why you might have seen on the news these crazy auroras going all the way as far down south as Big Bear. So yeah, I would recommend doing it soon and doing it during winter. So maybe next winter though.
Thank you.
Yeah, of course. Oh yes.
What are some of the causes for? Not what are some of the causes. What are some of the theories for why enhanced aurora occur?
That's a great question. So the current leading theory is that there's a parallel electric field. It's parallel to Earth's magnetosphere or magnetic field. That's about as much as I can tell you. My mentors possess all that knowledge. So yeah, I can probably point you in the direction of some papers later on, but unfortunately, don't want to give you misinformation tonight. Yes?
So you're saying that field interacts differently? What is the particles?
Yeah, so enhanced auroras, we think, is a different component, a different mechanism at work that's causing it, which is why we want to do all this research to characterize it and to hopefully get that data with a rocket. We don't fully understand how it is, we just have theories in mind. And there have been several theories that have also kind of been disproven. So. Yes.
Did you have any background in coding?
Did I have any? Sorry, continue.
Before you started the program, did you have any background in coding?
Did I have any background in coding before I started this internship? So I took a class in Python, the Python language, the spring semester before I did this internship. So I did have a bit of coding experience. All my research was coded in Python because that was the only language that I knew and it was the easiest to work with. But some of my other fellow interns had zero computer science knowledge upon starting the internship, and they still produce incredible results and incredible projects. So they picked it up really fast, and it's something that with time and effort can definitely be learned.
Have you considered using cloud computing instead of upgrading your laptop?
Have I considered using cloud computing instead of upgrading my laptop? I have. I am not as tech savvy as I thought I was. This internship showed me that I know absolutely nothing about computers. I had to ask my friend what RAM was. So yeah, that's probably another reason why I ran into so many walls coding all my things. But that's a good idea. I'll have to look into that. Yeah.
It might be obvious, but why is it more common to see the northern lights in winter?
Why is it more common to see the northern lights in winter? It's mostly because it's darker. So a lot of the places when you go up north, especially. In winter it's dark for a long period of time. If you go during summer, it'll be light out, and you can't really see the northern lights if it's light because the sunlight's going to drown it out. So you definitely want to go to a dark environment. So winter is definitely the best time to do that. Yes.
Any details on the rockets?
Any details on the
Instrumentation
rockets?
sizes?
Okay, so unfortunately I can't give you too many details because it's a top secret proposal, but I can tell you that my mentor submitted the proposal, and unfortunately in August we heard back that this year they're not going to get funded. Largely the reason why, they're going to try again next year, so fingers crossed, but largely the reason why they wanted me to build this algorithm is because they need even more evidence to give the submitters, they need to give even more evidence to the reviewers, to NASA, that we can do this, that them giving us the grant wouldn't be a waste of money or time. So that's why we built this, and that's why they're going to continue their work trying to understand this, so make the proposal more rock solid, more concrete. So hopefully we'll see. Yes.
What will be your next objectives for enhancing your algorithm?
Okay, next objectives for enhancing my algorithm. So I'm in a point right now because of school and a bunch of other projects happening that I'm not entirely sure if I will return to this work. I did consider it. If I were to transfer to Berkeley and I get a job at the lab, I could definitely continue my work there. But yeah, right now I've pivoted to a project. I can't escape the Aurora thing, so now I'm studying Aurora, but on Jupiter and Saturn. So now that's taking up my time right now, but yeah, I'm not entirely sure what my next steps would be. Yeah, we'll see if I do eventually come back to it in the future. Yes?
Do you have advice, or do you want to share your strategies on overcoming imposters?
Overcoming imposter. So share my strategies for overcoming imposter syndrome. That is something, again, I'm very much still learning how to do. I think the biggest piece of advice, like I presented earlier, is you definitely need to remind yourself that you're not the only one feeling it. Actually, in week 1 of that internship, they put all the interns in a room. The mentors left us in the room to talk to each other about our feelings. And we had to discuss all these feelings of doubt that we were experiencing, anxiety, and we found at the end of the day that all of us felt the same. We all had imposter syndrome, even if they were a lot further along in their education, or even if they did have prior research experience. So it definitely affects all of us, especially your peers. And it's important to remind yourself of that this experience is shared. It's not just you alone in that feeling. Yeah, also, the imposter syndrome lessens when you are more confident in the thing that you're studying. So if you actually study for that exam, you will feel more confident, of course. I learned that this semester, for sure does. Oh wow, studying does help.
As far as the rocket is concerned, why not contact Elon Musk?
Okay, as far as the rocket is concerned, why not contact Elon Musk? I'm not sure. I'm not in charge of the rocket proposal. That's a question for my mentors. I'm not entirely sure. The lab that we work with, the Space Sciences Lab, has a lot of affiliations with NASA. So I assume it's also that too, just the amount of work that they've done with the organization. How long is too long for me to stand up here before it gets too awkward? Yes?
Just to kind of reiterate, so the green is higher in the enhanced?
Exactly, yes. So it has much more green than it does blue, and that's signaling to us that it's caused by a different process. Yeah, so that's why we're looking at just the green and blue light specifically. We don't really care about the red light and things like that. Yes?
Is it known if there needs to be a higher intensity of aurora in order for these unique auroral features to show up?
Okay, so is there known if there needs to be a higher intensity of aurora?
Like more particles hitting the magnetosphere?
I actually don't have an answer to that question. I'm not sure. The actual physics, that's something that's way out of my league. I read a bunch of research papers explaining the mechanisms behind it, and I had so many question marks in the margins. Yeah, so I don't know if it's correlated at all to how much activity there is. I do know, though, that the more active the sun is, the more particles are hitting our magnetosphere, the more aurora that you will get inevitably. That's why in this period of solar maximum, we're getting more aurora. So again, the enhanced aurora we think is happening as often as half the time, as 50% of the time as regular aurora. So I guess you could say if there's more activity from the sun, then yeah, you'll see more enhanced aurora and regular aurora too. Yes?
Would you say that going to a community college has just really given you a lot more opportunity than any other way?
Okay, yeah, so the question was, would you say that going to community college has given me more opportunities? Would I say that it's given me more opportunities than some other path? I would absolutely say yes. I am a huge proponent of community college now, especially that I've experienced the benefits of it. Changing my major at a four-year university would have been a headache of a process, especially from such a stark jump from department to department, journalism to physics. It also would cost me a lot more money. Yeah, so I'm going to school here for a much cheaper price than I would somewhere else. And also, when I graduated high school, I didn't really know what I wanted to do with my life, and I could not imagine how difficult it would be going to a four-year and trying to figure it out there. Yeah, also being here, it's a lot closer of an environment, so you have a lower student-to-teacher ratio, which helps you build those personal connections with those teachers, which it's very, very helpful to have. Lots of guidance and mentorship. OCC is a very cool place to be. We're a little spoiled here. I like to say that we're the Ivy League of community colleges. What other, there's only so many schools that have planetariums.
Go Pirates.
Yeah, go Pirates. Anything else? I could stay up here for a long time and answer questions. Yes.
You said procrastination is one of your biggest weaknesses.
Correct.
How many minutes before tonight's presentation did you finish preparing?
So the question was, procrastination is one of my biggest weaknesses. How many minutes before starting this presentation did I prepare? Also, as my older brother, he has seen my procrastination from childhood to now. So I actually, ironically enough, I made this presentation like a month and a half ago because I was procrastinating my homework at the time. I didn't want to do my calc homework, so I was like, you know what, I'll knock this presentation out of the way. And then I just kept going back to it and adding more and more, the more assignments I wanted to avoid. Yeah, but I did, in fact, tweak it about an hour before you all came here today. So, yeah, so definitely still have to fix that habit, but it's worked for me thus far. Yes.
Where are you applying to?
Where am I applying to? Okay, so I just submitted my UC applications. Thank you. I submitted it an hour before the deadline. Also, I didn't even think I was going to apply this cycle because I thought I wanted to spend an extra year at OCC. That's still very much a possibility. It'll just depend on where I get accepted to. But I applied from north to south, UC San Diego, UCI, UCLA, which is really want UCLA, and I hope they want me too. UC Santa Barbara, UC Santa Cruz, and UC Berkeley. So those are where I applied to. Also, did not think I would ever go to school like as cool as my targets, which are Berkeley and UCLA, because again, my GPA in high school is not something to be proud of. But yeah, if I can do it, you can do it too. Yes.
Do you feel like your high school prepared you for college?
So I feel like high school prepared me for college. In ways, definitely. It definitely humbled me and built a lot of character. I'm also lucky that I had some really incredible teachers, two of whom are here today, and I'm very grateful they're here. Also, my journalism teacher is here today as well. Yeah, so it definitely provided me with a bit of a support system, including teachers, including friends, and yeah. I think it definitely taught me a lot about myself. So I think I took more of high school, the experience, I learned a lot more socially, I think, and about life than I did academically, because a lot of the things that I learned in high school I'm not completely applying now. I will say, though, the only reason I have the job that I do, which is public speaking for a living, and the only reason why I'm able to be up here today speaking to you all, is because I took Model UN in high school. And that completely forced me out of my shell. And I went from being too scared to ask for ketchup at McDonald's and crying at the restaurant I used to work at because I hated talking to people, to being able to speak to a crowd of like 150 kids all the time. So yeah, learned a lot of external skills for sure. I will stand here, that's okay. Yes.
Resources to me, that's very impressive, for one, and two, any comment on Jupiter and
The moon or the aurora?
the two things you're working on Jupiter and
Oh, okay. So he's asking about the research I'm doing now on Jupiter, or aurora on Jupiter and Saturn. So we're kind of at a road bump right now. We finally found places where we can access data, but when we download the files, it tells us a whole lot of nothing. So we need to figure out how to interpret that data in a better way. So I will be spending my intercession working on that project and trying to understand it. We're gatekeeping the data. Yes.
where are you doing that?
Sorry, what was
Where
it?
are you doing that research on?
Where am I doing that research? I'm doing it here at OCC. So every year OCC holds a research symposium where students across all disciplines, so even students in humanities, or some people do even performances, like dance performances, we do work over the semester, over the 2 semesters, and then present our findings or story, if you will, at this research symposium. I've partnered up with 2 friends of mine, also in the astronomy and physics world, and my same professor that changed my whole life. So we're studying that right now. Yeah, here at OCC. Great question.
I have a
Is
silly
it-
question.
Yeah. Okay. Yes.
Did you ever discuss the concept of imposter syndrome with any of your mentors at Berkeley?
Do I?
And did they admit to it?
Yeah. So I did ask my mentors if they experienced imposter syndrome, like I did, and the answer was yes. A lot of them did. Not just my own specifically, but some other people's mentors. They gave us presentations on.
It's everywhere. It's
Yeah.
rampant in everything, not just the professions, in any endeavor that you care about.
Exactly.
You've
Yes.
always got this niggling feeling that somebody's going to find out that you don't really know the things you're projecting.
Exactly. Yeah. It's a very difficult feeling to deal with, and one that has to be conquered eventually. But yeah, even full-time doctors and researchers are experiencing that too. It's everywhere. All right, and I think with that question is where we're going to end it off for tonight. I will be in the lobby if any of you have some lingering questions. But again, thank you all for being here with me. I hope you have a great day.